presentation voice.
Hello and welcome.
So, a baby X-ray has managed an X-ray between...
Okay, you're on.
Okay, I'm going to talk to you today about the INCC program. It's the International Neutron Coincidence Counting Program. Since I'm a software person, I'm going to describe the installation, configuration, and use of the software. And I won't go too much into the physics behind the algorithms and why this software is so great. That's for another lecture and a physicist to assist, unless someone here wants to chime in. Now, the first thing to notice is that we call it international. Now, this is because it was written for more than just domestic use and for multiple applications. In particular, the IAEA uses it for a lot of work in facilities. This morning, one of my kids asked me, "Dad, what does international mean?" He's 6. And he thought that the neutrons were international. So he said, "Are they Scottish and Spanish?" And so we just started laughing. So that's the only reason we say international is because of the IAEA use there. And we do have 3 versions of the software. We have the domestic version. We have one we made for Euratom and one for the IAEA. And they're almost identical. There's very slight differences based on the requirements. Now, historically, the software has been authored primarily by Merlin Crick and Bill Harker. But there's been many contributors over the years to specific algorithms or improvements or the testing, and we've got a lot of input. There's a lot of mental content to the software that's been built up over many years. So it's a serious nuclear code with a rich history, and I believe it's fairly well considered. I primarily do maintenance on it, by the way. We have added a few new features recently. These were the objectives of the software. We wanted to perform data collection and analysis of neutron data collected from shift registers. There's a series of those. There's the JSR, and the one that we use now is called the ANSR. We wanted to automate common analysis procedures so that they weren't being done by hand or in Excel. Because a lot of the users of this are not physicists. They're people that may not be that well versed in either the physics or the use of a computer. They may, some of the inspectors, for example, are individuals with other kinds of qualities, but they need to be able to use the software in difficult environments. They need to get the data collected and then be able to analyze it. So we tried to address that. One of the things that was added in over the last few years is the software is not just a standalone application letting you run a detector and then analyze it. You can now work it with some of the other software tools that we have here in our group, notably radiation review, operator review, integrated review. And so the way that works, and we'll discuss a little bit more later on, is you may identify events of interest in radiation data using radiation review, and then you can invoke INCC to do the neutron analysis on that data collected that's identified in the other tool. So they work together. There's a lot of configuration in INCC that's very specific to the facility and the detector and the material types you're dealing with. So there's hundreds of parameters actually, so building the thing up to where it can be used in a specific situation takes a little bit of time. And that's typically done by one or more experts. As I mentioned before, we have 3 versions that don't really differ very much: IAEA, Euratom, and domestic. All are available now. Now, since the software, we'll talk about installing it. I've improved the installation procedure. Well, first let me tell you that we now have version 505, and I've enhanced the version numbering scheme. It's 505.5 because every time I make a tiny fix, that just fixes something small, I'll bump that last number up. But the general functional content is specified by 505. And so that won't change, the user guide won't change, but you may get different version numbers as I quietly fix things that come up. We have a new installation procedure that I've improved from the old one, which is pretty old. You just simply get an executable and click on it. You can install it anywhere on the computer that you want. You can install it over the existing installation, and the installer will preserve the database that's already there. It also makes an automatic backup of it. I still recommend anyone using this to always be backing up their data anyway, not depend on anything else, because the data is critical. It's easy to back up. There's a backup procedure within INCC, and you can just copy the whole installation folder in one fell swoop. Which I mentioned the backup procedure right here. You can go to the File menu, and there's an operation called Backup All Data. Now INCC does, for data collection, it actually has a real database. It's not flat files or something dependent on the Microsoft operating system. It's an actual database. It was chosen for performance and for compressibility of the data. And I think generally it works pretty well. It's fast. That was more important several years ago with slower CPUs. It's not important now that it be fast because the data collection coming from the instruments is slower than the CPU cycles on the computer. So, but it's still nice to have the database there. You can have multiple databases, and in the same fashion that you can back them up, you can pull them in. So with INCC now, you can have 4 or 5 installed on the same computer with different databases, or you can have it in one place and throw the databases around. We're working on more improvements to database management, by the way. Now, once you use it, well, it's an old one called, it used to be called RAMA, and now it's called BirdStep, but it's been around for 15 years. It's not Microsoft Access. It's not Oracle. The database product actually is a good one. It's used internally to a lot of professional development tools, but you don't know that because they don't advertise the database underneath it. It's also used as a mobile database for Windows CE and other mobile platforms because it's small and fast. And I was recently talking to the people they're actually a Norwegian company, and they have a primary office up in Seattle. And I just spoke to them this week actually about their latest versions, and they're going quite well, and they've got some good products. So I'd like to stick with that database. So we can go to Access. Pardon me? What's the name of this company? The company is now called BirdStep. I think they mean it has a lightweight footprint, and that's translated from Norwegian probably. Now once you've installed it, you want to set up for a facility. Now here is a lot of work to do. As you can see in bullet point 1 there, we have you will define a facility and materials balance area. That's optional, and 1 or more detectors. So you just simply use IDs for those. It might be in your facility that you have 10 detectors, so you'll declare 10 of those. There's simple menu items that you say, add a detector, and you type in 1, 2, 3, and it's in there. And once you've done that, you then have to set the measurement parameters for each detector, and that's more complicated. And so in bullet point number 3 there, you'll see that there's gate length, the high voltage, the pre-delay, the efficiency, dead times, gate fractions, and there's a few others also, which those of you that know a lot about detectors already know what that means. So for each detector, you will know what that's supposed to be somehow, and you will put that in. That's why I say it requires some expert knowledge to configure this initially. Now beyond that, the way neutron analysis works is it's specific to the material that you're measuring. And you know a lot of properties about that. And again, I'm not a physicist, so I'll just speak to some of my understanding of it. There's matrix concerns, the multiplication of the material, shielding issues, depending on the detector and all kinds of things like that. So you'll be specifying those kinds of details on a per material basis, on a per analysis algorithm basis. And we have many analysis algorithms to choose from. Again, you're the experts, and you'll say, I want to do curing ratio with these three materials, and here's the parameters for that. And we'll go into more detail on some of those settings in a moment. Then there's the calibration coefficients, and that has to do with calibrating the detector with standards. Again, that's an expert thing, but all the facility to do that is here in the software. And once it's captured, you can, well, we have more configuration, which we'll look at here, more setup. Stratum ID is another thing that you add in. Stratum rejection limits. Again, this is more detailed physics. So, isotopics is interesting. You can specify a variety of isotopics either externally, and you can create external files that are pulled in, or you can do it right in the software and write the file out. So you can see we're now 5 levels deep of configuration for measuring materials. And then you may have a default background for the detector in the area where you're measuring, and you can enter that in here. There's also a facility for taking background measurements of INCC. You can enter default values here. Normalization is another configuration step. Some of you would understand it better than I. We have test parameters. That's for data conditioning. So you're looking for outliers, ranges of rates that you're expecting. There's a bunch of defaults in there, and you can then set those and change them based on your application. The results of those are flagged in the output reports after a measurement analysis, whether things pass the test or not. There's a series of those. And then there's 2 kinds of error calculations that you can set. Okay, now let's look at the menus of the program. There's actually 2 modes of operation. Going upside down there. We have the inspection mode, which presumes everything's already been set up, and the inspector or the user doesn't have to go in and deal with any of the things we just saw: calibration, normalization, isotopics, et cetera, et cetera, et cetera. We also have the maintenance mode. The only difference in the menus here is we've activated this maintain menu here, which gives you access to a lot of parameters to set up. This is because we have 2 target audiences for the software. We have the user, the unsophisticated user, who goes in and uses it after it's already been set up, and then we have the scientist or expert who plays around and gets everything just right. Now I wanted to show you some of the differences in, or some of the different operations that are available in the software. This here is the file menu. You can see there's a variety of operations to import and export data. You can either do entire databases or you can do pieces of the data. So you've configured your detector and all those parameters. You can save those off and move them to another copy of INCC on another computer. You don't have to type in the 200 parameters again. They're just simple files that you push out and then pull in using the corresponding menu items here. For setup here, you see there's the facility menu that I mentioned before, where you specify facilities and detectors in the material balance area. Measurement parameters is the item that you use to pick a detector and set the parameters for the specific detector. Isotopics and composite isotopics are, you can either type in manually or pull in files externally, prepared elsewhere. And you can also enter the details about the items you're going to measure on an individual basis here. So you can, if you have 10 IDs with some properties, you can put those in there. Color item data is similar, but for color measurement. Now, Here's a whole lot more menus. And you can see there's a whole lot. So we can set up, starting on the upper left, calibration. Here's where you would pick your analysis methods. There's quite a few there. We've got known alpha, known n, multiplicity. There's 5 flavors of multiplicity. There's one new one called weighted multiplicity. There's the add source, screen ratio, truncated multiplicity. We have active measurement, things specific to color, active, passive, et cetera, et cetera. So in each one of those, which I'm not going to show you here because it would take too long, has multiple number of parameters specific to the analysis type that you set. The expert knows which analysis to pick for the material and the detector, and that's done here. And going down the list over here, we set up different parameters, area calculation. You can add material types to stratums. There's other things that I'm not sure how much they're used. Poison rod and glove box is used for some of the analysis. It's very specific. It's all in here. You can also, once you've collected data, if you think the database is too big or for some reason you want to eliminate some, there's a delete measurements feature. Going across here, let's pretend we've set everything up and we're ready to take a measurement. Well, now you have the choice of 8 types of measurements to pick. To do rates only, background, initial source, normalization, precision. Verification is the one where you're actually measuring material after you've calibrated and normalized and everything else. Hold up is a specific kind of measurement. And then going across that, once you have measurements, you've done initial analysis and the data is already in INCC, there's a couple of ways to reanalyze a couple of kinds of measurements. And then you can pull up an existing measurement, change a few parameters, and run it again. And then finally, what you're interested in is some kind of a report, so there's a variety of reports. There's 3 kinds, which I'll talk about in a moment. There's text reports, data export to Excel, and a couple of simple graphs. And now we can look at some dialogues. This is how you set up a detector. You can see we've got hardware-specific things on this side, and over here, again, an expert knows what those are the dead time coefficients. An expert would know what those are supposed to be, perhaps by doing some experimental calibrations or analyzing previous data based on the facility and the material type and the kind of detector. Here also you'll notice that there's the ability there's more than one kind of shift register. We default to AMSR. Who knows, these things are really driven off of serial ports off the computer, and who knows what the COM port is really going to be, so you get to specify that here. I think we have provision for 10, and I'm going to bump that up to 256. So, because a lot of computers don't have actual serial ports anymore, they have only USB, and so these adapters that you get will give you 256 virtual COM ports. And we've seen in the field that sometimes you can't get the first 10, that you can't predict that. So, and it depends on the XP operating system and other things that have been plugged in the computer, and it's unpredictable. So I want to make sure that there's always some COM port available who cares what the number is. That'll be, maybe 0.8 version, 5.8, 5.8. Now here's an acquiring data dialog. So you say, I'm going to measure this. You may have already typed in your items. You can see here there's an item ID already selected in the list. You may have multiple material types. Here it's PU. You've got a declared mass. You have the opportunity with every measurement to put in a unique comment. You can tell it how long to actually run the detector. In this case, it's 100 seconds. You can see there's 4 choices here, radio buttons, to use different kinds of, I guess there's 4 choices for taking a measurement. Some of them will stop based on the precision, and others will just use the number of cycles, which down here is specified as 3. So So the other options you have, or you can specify whether you want to apply the quality control test to the data, whether you want to automatically print the results out at the end. Some people like to do that in a production environment. You're measuring, and the reports are just coming out over here, and you don't have to go over there and come back, generate the reports later. There's a lot of flexibility here, so the conditions you're working in may be, convenient or not, so you can arrange this to do what you need to do. Some of the differences we have here is you don't need to use a shift register. You can also reacquire data that's already, a measurement that's already in the database. You can do that if you want to change a parameter. It's similar to a reanalysis. You can actually type in measurement data on a little editor if you want to, if you're experimenting with how INCC is computing. That's really tedious, but it can be useful. There's also a couple of disk file formats that evolved in the past that people were using to move data in specific situations, so you can pull that data in just like that. So you have some flexibility there. Now, I mentioned the reanalysis before. Once you've already done a measurement, doing a reanalysis gives you a choice dialog like this, where every measurement you have, in this case it's verification measurements, is displayed here. You can pick one or more to reanalyze. You click OK, and you get the same result or a different result depending on how your parameters are set. One of the things that it will do is it won't replace the existing measurement. It will instead, you can see that one at the top there, D8, the time is exactly 1 second later than the one previous to it. And so what I did is I changed the item ID and nothing else when I did the reanalysis. So the original measurement is there at 14:52:48. The reanalyzed one is made unique by bumping the measurement time up by 1 second. So no data is overwritten. The original measurement is still there. Here's the reanalysis dialog showing you what you can change when you go through that. You can change just about everything from the declarations there. And you have the option down here to replace the original measurement or not. I have it checked here. You can also apply the QC tests, quality control tests. You can print the results automatically. It's similar to a standard measurement. And here's something that apparently is important. These inventory codes, it's some kind of standard. I don't know if that's domestic or not, but it's in here. So for every measurement, you have 2 of these kinds of codes specified. They're in pull-down boxes. These 2 help boxes tell you what the codes mean. So I'm sure there was a requirement from some projects that drove that. Now, here's a page where you specify the isotopics. And you can have many of these. So you may have a campaign that maybe you have 3 kinds because of the target material you're using. I don't know what the motivation is, but you see you've got all the different PU isotopes here. And you have a facility to read and write these things and save them out as you need to move them around. There's also some standard codes for some of the kinds of isotopics, saying where it came from, whether it's from the operator or the inspector. Now, how do you get the results? Well, there's a variety of ways to look at the results, and there's also a lot of data to report to you. There's the dozens, hundreds of different parameters possibly. There's the raw data. There's the measurement results. So the textual output can get rather large. So you can optionally you can choose what to look at here. That's all that is. Now, this is the facility and inspection setup dialog. So these settings apply to all reports that INCC will generate. But on an individual basis, you can customize that at any time, so you're not forced to one system-wide setting. So you have the textual reports. You have these three selections down here. The measurement, verification, and hold-up summary are really common delimited files where you pick of about 120 choices of results and parameter settings, and you pump that out to a file. You pull that into Excel, which I know a lot of people do. So if you don't want to work with the textual reports, you can work right in Excel with the results. And then we have a couple of simple plot graphs, which I don't have a slide to show right now. When you generate a report after the fact manually, you have the same ability to choose the components of the report here. They can be as full-fledged or as succinct as you want. Here's the Excel export, the measurement, the summary report. You just pick a range of measurements to look at, and then there's a huge list of things here, all kinds of parameters. You have to scroll down and pick the ones that you want. The heading that's displayed there, this one, for example, the one that's checked says multiplicity, pre-delay, and gate width. That's what shows up in the header file of the common delimited file. So when you pull it into Excel, that's what you see. Now, let's talk about the health system. We have from within the application, we have an online help that's based on the software user manual. And the manual itself is actually quite good. It has a lot of the physics in it and a lot of theory, as well as the operation of the software. So I recommend spending some time with it. And you can access the other part of a general software application help system is how do you get a hold of the people that maintain the software. And my email address is on the Help About box in the software. And I believe I may have the address of the physicist, but I'm not sure. I don't know if anyone's agreed to do that. Now here's this is what the help looks like. Just to give you an idea of the content. There's all the analysis algorithms. There's the theory behind it. We have references of, where you can go actually read in more detail about here's an example of some of the references. The famous Panda manual is number one. You can get access to this user manual once you've installed INCC. Above here, you'll see that you just go to the INCC menu item, and it's one of the elements here, the PDF file. You just open it up, and you can turn it out. Now, I'll show you a little bit next of how INCC works with radiation review, which is one of our other tools. This is if you're presuming you've pulled in some data that was collected from some source with the radiation review tool, you've identified some events, measurement peaks of interest, you've isolated them, perhaps you've done a little bit of expert or heuristic matching of the events, pulling out some bad cycles. Now you have some events of interest that you want to analyze in INCC. That should go off. Sorry about that. This thing just woke up by itself. I don't know why. It's a hardware problem. I don't know why I did that. But it was easy to fix. Well, what I'm trying to set up here is that you've prepared data at radiation review for INCC to use. And what radiation review produces is some physical files in the file system that have all of the measurement data per measurement event in an individual file. And each file is identified by a time and date scheme. So what INCC does is it looks in a shared location for these files, opens them up, processes the data content as if it was a measurement that had taken place, writes the measurement data and the details of the measurement, including various parameters and everything that are set, into the database, and then it will either perform an analysis for you automatically, depending on how it's been configured, or you can go in and manually analyze the measurements. Now, one of the restrictions is that you have to have already defined the detector involved in INCC itself prior to doing the import. Okay, I just said this. So after you've imported the measurements, the binary files that are created by radiation review are cleaned up automatically for you, so there's no work there for you. Depending on how it's configured, it may automatically, it's more like a batch process. It can just print the results out. There's some settings you can do for dealing with data from the other tools. You may have already in INCC a detector in some existing measurements, and you may wish to match the events that you're seeing in radiation review with these existing measurements. So the matching can occur within a certain range of time, so we give you the ability to specify and tailor the bandwidth, the matching criteria to facilitate batch operation of this. And when you're importing, you'll see this dialog here. And this tells you some details of each measurement that you've identified in radiation review. Maybe you don't want to import all 50 of them. You're just interested in a few. So here's your chance to just select the ones that you want. You can see here we've got the detector ID that matches item ID, the kind of measurement that it is, the date and time, and the actual name of the file on the right. In this case, I've picked a couple of them. This is what you see after you've selected the measurement for import. Again, you get to specify more things about it and can change it at that point. It's a lot like a reanalysis. So the inventory codes, declared mass, kind of material, item ID, etc. You can all change that here before it gets written into the INCC database. There's another step for curium ratio, which is shown here, where you're going to enter data specific to that analysis. This is a little bit, there's extra work in this case. Finally, you see the same thing here that we saw before about generating reports. So the actual act of importing these measurements, see, you didn't take these measurements. They were done in unattended mode probably. But when you're pulling them into INCC, you're going through the same steps you would do when you're specifying certain steps in the measurement and then the output results. So here you're picking what you want in your reports. And then finally, I think that's it, actually. So, if there's any questions, I'll answer them now.
I have a question.
Yes.
Can you set up the voltage using INCC, or you have to go by manufacturer indigenous program which starts the detector?
You can't change the high voltage limit on there, on the measurement. Let's go ahead and we'll run INCC here. The answer is yes, as far as I know. And we do have a version that will actually, it does some kind of a settling, balancing on the voltage. There's one kind of detector where there was some desire to do that. let me show. Let's look at the dialog again for setting up a detector. Well, I guess there we go. If I run INCC, maintain menu, and well, here's the measurement parameters menu. Is that okay, Morag?
Yep, looks good.
Okay. So here you've got you got a high voltage right there. Now, if there's more detailed configuration for the detector, it's not on in INCC specifically.
For some reason, when we were in here with Doug last year, we were unable to talk to this JCC51 Canberra Neutron camp, active weather camper, without going through the program, setup program which Canberra provides.
Okay.
So what we did, we had to start with this Canberra program from JSR 14, and then use on top of this, use the...
Okay. So here we have JSR 11 and 12.
Yeah, because you don't have a 14.
Right, okay. Okay. Well, maybe we need to add that.
This is the new version of shift register, which is developed from Canberra. It's automatically packaged with the counter. If you buy the counter, you get 14 because now it's cheaper.
Well, if you perceive need for that, I mean, it's not...
No, I would like to have those.
Okay. Well, let's talk about that.
Yes.
That's how INCC has evolved in the past, is
Right.
exactly that kind of incremental need increases, and then we'll just add JSR 14 here, maybe 2 more parameters or something. So I'll be glad to work with you on that. I'll show you, what can I show you? Well, here's how, when you're integrated with other tools, INCC, in this case, is integrated with radiation review and something called the quark detector measurement software. So if I click on this, it pops up radiation review, and there are some nice looking radiation peaks. And we have a, let's see if I can get a, here we are. So here we've got some identified peaks here, and if I wanted to go back to INCC and see if that was it, to find the matching measurement to that, I just simply do that. In this case, the installation of INCC I have does not have this data in its database, so the software's telling me, sorry. This was set up to use the FDMS program, which would be, brought up here, which I'm not going to do because this is an INCC lecture. But this just gives you an idea of the kind of integration activity, so you can use these tools together.
Joe, can you specify how one goes about getting a version of INCC and how one would get INCC to their customers and export control issues or anything?
Yeah, there's some complexity with that. It's the international software, okay? Part of what that means is that it has a long history and a complex history of funding and authorship and licensing. Now, it's already licensed commercially. There's at least 3 vendors. There's Canberra, Ortec, although that might be Canberra now, I don't know. EG&G, I don't know.
Not yet.
And then there was British Nuclear Fuels. They, I believe, had a license, or it might have been a tailored license to the one detector called the Superhang. So I've had requests recently from outside Los Alamos for INCC, and I've ended up directing them directly to Canberra. Part of Canberra's license is that they have to sell it commercially without selling people detectors. They want to sell people everything because that's what a company would want to do. But the license requirement is that if someone wants only INCC, they have to deliver it. So that's the answer for people outside the lab. If you're working with somebody collaboratively, in the domestic complex or an international customer, then part of that arrangement is INCC is part of that. And so, but that's specific, and if you deliver it outside of the U.S. or to a foreign national in the U.S., you have to get export approval to do that. And we have all that's worked out.
We worked last year.
Yes, we've done that. I worked with you on that, Joseph, and I've worked with several other people on it. and it's routine, and we've been doing it for several years, subject to the constraints that all exports have. So if somebody wants it that you're working with, you can get the latest copy of the software from me, or you can probably ask anyone in the software section, where's, INCC, current INCC for domestic, and they can give it to you. But you do have to pay attention to the export restrictions and where it's going. And so that's pretty simple. I won't tell you what it costs to the external person from Canberra. It's not cheap.
It's not for sure.
What can you tell us about if there's a batch mode version, or is that just a wild rumor?
Ah, okay. No, it's not a rumor. It's vicious gossip. No.
Well, push that out then.
No, there's a version for INCC has many incarnations that were made for specific detectors or unique situations. The most generic version of the software is INCC, which I've just presented. And so what I did for one of these more targeted versions that had most of the analysis removed and had some other specific things that were different, is they wanted to be able to specify existing measurements by, say, the hundreds in an existing database, and not have to go in there and manually keep saying, okay, 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 okay. Because you can get the list of hundreds of measurements and then click on 10 of them and reanalyze them and change the data manually one at a time. That turns out to be really tedious. You want to do all 200 measurements, and you want to change a couple of parameters to see where the numbers go real quickly. So what we do is we have a mechanism to export enough information about each measurement to a comma delimited file that you can pull into Excel, edit it with the changes that you want for, like declared mass or maybe efficiency or whatever the fields are, and then you can run that file back through. It will find the measurement, do a reanalysis of the measurement with the change parameters, store it in the database, and optionally generate a report. So yes, we have that working now. And that is going to be a part of INCC in the near future. I don't know when yet. Anything else? It's an old code, okay, and we are going to be making improvements architecturally to it so we can combine it with modern pieces of software in an easier way. And by that I mean we should have the ability to deploy the analysis part of INCC separately than the data collection part. They should even be able to live on different computers. You should be able to collect data from your laptop connected to the detector while you're writing the data to a database that may be in another building or another city. And so some of the architectural plans that we have will support that kind of stuff. If anybody wants it, I don't know. So again, input from the user community is what drives the software. So okay. Thank you very much.